I'm Jon Beer from Jon Beer Contracting, and we're here at the Fine Homebuilding House in Cornwall, New York. Our goal here is generally to have a pretty tight house. We're shooting for less than 1 ACH, our blower door test. So I'm going to kind of run through our decisions on different control layers. When it came to dealing with thermal, we have a couple of different considerations. The old part of the house is a 2x4 framing, so we're limited in depth to meet energy code. The wall assembly is also 2x4. It's got a fiberboard sheathing, a 1-inch air gap, and then a veneer brick on the exterior. We have no way to access that fiberboard sheathing, so it was important for us to decide what our thermal product was going to be, which is closed cell spray foam to meet energy code. In the old sections, we're hitting 2 birds with 1 stone, thermal and vapor in that one closed cell layer. On the new second story and addition, we have a 2x6 wall assembly. We have a zip sheathing on the outside. So our water barrier is there at the zip. We have a rain screen assembly to help with that. And we're using open cell spray foam in those because we have the cavity depth to use that material. It also lets us spend a little bit less money than using closed cell everywhere. So in that assembly, the vapor barrier is on the outside of the sheathing. So that's basically thermal and vapor is being handled by 2 different types of spray foam and the zip sheathing on the newer structure. We're dealing with bulk water with a metal roof with underlayment, a peel and stick meant to go underneath metal, and cladding, which is a 7/16 shiplap cypress made by Nakamoto. We'll sit on a core event rain screen, so that allows us to maintain a drainage channel all the way down the outside assembly, including the areas where we transition from sheathing to brick. There's a point where the veneer brick ends, and that's where the old original soffit used to begin. And that veneer brick is flush to the face of the new sheathing. There was about 1 foot of space above the veneer brick below the new second floor structure where we had a kind of rectangular void almost all the way around the house. From a water shedding detail, that was an important area to really spend a lot of time on and design the right solution so that any water coming down the face of the zip doesn't go behind the veneer brick and enter our original wall assembly. So using SketchUp again, I created a model for that assembly. It's basically a small framed wall with a piece of aluminum, a site bent aluminum drip edge that comes down the brick. It's taped to the existing fiberboard sheathing, comes down, goes over the brick and drops down with a hem on the bottom. Then our new rectangular block, we pre-made them on the ground. We taped the underside of them beforehand because we wouldn't be able to get underneath there. And then we applied them directly to the building and zip taped the seam where the sheathing connected on the wall. Definitely a little bit of a mystery as to like what we were going to find when we did the demo, and then B, how would we deal with it. It turned out to be a relatively simple solution, though it was kind of time intensive. The building's now been dried in for several months since November, and we haven't had any issues at that connection point. Everything seems to be draining just fine. So at the end of the day, when it comes to dealing with bulk water, gravity is the kind of primary director of how water moves. When it comes to designing a system that deals with shedding bulk water, the thing we always go back to is the principle of like shingle style layering, where you start at the bottom and layer your materials so that the water always has a path to find its way out assisted by gravity. Our framing obeys those same principles, so we're trying to create opportunities for any water that could be trapped for a variety of reasons, whether it's driving rain, whether it's snow melt, it's ice that's melting or expanding and contracting, or a hot spot on the interior that's causing ice melt. We want that water to find its way out. All of our decisions about this particular block that we built to bridge the old and the new, siding assemblies, overhangs, they're all thinking about that principle that water needs to be able to find its way out and not get stuck anywhere. Air is our last control layer. We're primarily dealing with that from the inside, though we have some details at penetrations. Pre-installation through the entire house, we're going to go through and do a rigorous air seal with canned spray foam. hitting the bottom plates, hitting the top plates, hitting any roof to wall sheathing and framing connections. While I trust my spray foam sub, I want to have a belt and suspenders approach. Before he comes in, we're going to go through and hit all of those areas, any hard to reach spots, any things that are currently or will be covered by ductwork. So that's one method we're using to deal with air sealing from the interior. Our window openings on the second story in the new sheathing, we're using Siga products to create an air sealing buffer basically in the width of each window. We're taping from the outside, we're leaving the bottom flange open, and then we're using their IS tape on the interior to totally air seal the window assembly to the framing. So on the second story, we're dealing with that. First story, existing openings in that stretch between structural 2x4 and veneer brick. We are air sealing with the Siga tape, and then using a combination of Siga tapes and Loctite tight foam to seal those openings. I think the priority for us is definitely on air sealing, and that's where the bulk of our work will lie. The rest of our control layers, we're relying a lot on our building materials, but also like a quality install of them to make sure our house is well protected from the elements.